I'm going to get started. I'm recording y'all today because I'm remembering. I don't always remember to do it this class period, but that's always my goal. We're going to start with the back side of those notes. So make sure that you have notes, and this is what they look like. So this is the back side of the notes that we started last class. We did the front side. We didn't get a chance to get to the back side. So we're going to finish with the back side now. On the back side, up at the top, it says a system of linear inequalities is a set of two or more linear inequalities with the same number of variables. So it also says the solution. The solution, let's back up. The solution to just lines, if you got a couple of lines or two lines, the solution is where they cross, right? Yeah, y'all remember that? And there's three situations. They might cross, and that's your solution. The other situation that happens is that you got parallel lines and they never cross. There's no solution. The last situation that happens is that you've got like the same line on top of each other and there's infinitely many solutions. Do y'all remember that from last class? Okay, today we're going to do the same thing, but we're graphing inequalities. So an inequality means that that's when we shade above the line or below the line, or we've got that solid or dashed line. So what happens today is that the solution is the overlapping shaded part. And we'll go through this. It'll be easier to see when we actually graph some of these. So the solution to a system of inequalities is the overlapping shaded region. The solution to inequalities, system of inequalities, is that overlapping shaded region. So we have two inequalities here. We're going to go to graph them. So to graph the first one, it's similar to when we graph lines. We're going to go down to -3. We're going to put a point, and I know that this is going to be a dashed line, so I'm going to put an open circle. And then my slope says go up 1 and over 2. I'm kind of going fast because this is a review. We already learned how to graph an inequality. And so when I go to connect these dots, I need to make sure it's a dashed line. And then I'm not completely done yet because it says that I need to shade. What's that symbol tell me? And where does that tell me to shade? It is to the left. Where else? We just did a warm up, guys. Y'all are making me sad. It is to the left, but where else? Down. I've heard some of y'all, but not enough of y'all. Less than is down or below. It is also left, but it's not as much left when you look at a line like this. So below, think in your mind where you think below is. Hopefully you are right, but I'm going to shade below. Below is down here. I'm going to go to graph the other one. This one, I'm going to go up to 2 and put a point. This is going to be a solid line because I have the solid line underneath the inequality symbol. And the slope tells me to do what? Down 1 over 1. Where does that symbol tell me to shade? Above or below? Above. So think about where you think shading above is. The solution is the overlapping shaded region. So it is here. That is my solution right here. It's this overlapping shaded region and anywhere along the solid line. You are not any solutions along the dotted line. So part 6 kind of tags along with this one. It says, use the system and its graph to determine if the following points are part of the solution set. Well, I'm going to take and I'm going to go plot each one of these points and I'm going to see if they're inside that shaded region. The first one is the point 3, 1. This is why we did that practice dot to dot picture. So I'm going to go over 3 and then up 1 and I'm going to put a point. Is that inside the overlapping shaded region? No. No. That is not inside the overlapping shaded region. So now I'm going to go to 5, negative 3, over 5, and down 2, down 3. Oh, that's not 3 actually. Is that inside the overlapping shaded region? It isn't inside the overlapping shaded region, but yes, it is a solution because it's along the solid line that borders that overlapping shaded region. So you can be on a solid line. Next point, over 6, down 2. Is that in the overlapping shaded region? Yes. And the last one is 6, 0. Is that inside the overlapping shaded region? No, it borders it, but it's on a dashed line. The dashed line has holes, so no, that one doesn't work. Any questions on how we can determine if points are within the shaded region or within the solution set? No, we good with that? Okay, so let's do 2 more examples where we're going to graph inequalities. So let's do this one. So I'm going to start with the first line. My y-intercept is 2, so I'm going to go up to 2 and I'm going to put a point. This is going to be a solid line because there's a solid line underneath the inequality symbol. The slope is -1, so I'm going to go down 1 over 1, or to save time, I could go down 2 over 2 or down 3 over 3. How did I get what? I have to go first and plot the y-intercept. The y-intercept is 2, so I go up to 2. And then the slope is -1. So -1 tells me that I'll go down 1 over 1, down 1 over 1, down 1 over 1. And I can use symmetry to also go up 1 and left 1, up 1, left 1. I'm just not putting every single point. And if you guys need help graphing, you can go back and watch my video where I do a whole lesson on graphing lines and inequalities. The next one, my y-intercept is at -1, so I go put a point at -1. This one's going to be a dashed line, so I'm going to put little open circles so I remember it will be dashed. The slope is 3, which is the same thing as 3/1, so I'll go up 3 and then over 1. Oh, I forgot to shade my other one. Before I get any further, I'm going to shade this one. Both of these look like that they are a less than symbol. Less than means shade where? Down. Okay, so for my first one, I'm going to shade down. Okay, I'm going to shade down on that one. Now I'm going to go back and connect my dots for my second line. That one also shades down. It's a little bit harder to see shade down for that one because to me, the lines are kind of more vertical. So one thing we can do is we can always start out with that line that's horizontal. And then if you start out with a horizontal line and you know that you're shading down, then you can kind of shift your graph to know where you actually shade. So can you see the overlapping shaded region? It is down here. That overlapping shaded region is down here. I like that better. You can see it. So the overlapping shaded region is where your solution is. It's where your solution is. And remember that it doesn't, you cannot be along the dashed line, but you could be along the solid line that borders that shaded region. Sometimes you will see graphs, and when they're already drawn, let me see if it will let me take some off. Actually, I think I can do it with, we'll see. Sometimes you'll see graphs and they actually look like this where they don't show both shaded parts. It only shows the part where they overlap. So I think that there's a question on your test and one of them shows it like this, where it shows both sides and where they overlap. And there's another question where it only shows the overlap part. Either way is correct. It's not wrong. Usually just shading both sides and where they overlap is easier because who wants to go back and erase? So there is that one. We got one more that we're going to do as an example. So what I would like for you guys to do is to try it. I'm going to do it up on the board, but I'm not going to talk you through it. I want you to try it on your own and let's make sure that we get the same answer. The 3 weeks is upon us. And so some of you guys are not going to be passing my class. And I can guarantee that the amount of sympathy I will have for you when you don't pay attention or take notes is none. None. No sympathy. None. Did you guys get the same thing as me? Can anybody be brave and tell me that you made a mistake? What'd you do?
I put the line on like the wrong side, the one that has the two letters line.
Mm-hmm. Were you able to figure out what you did wrong?
I think so. I think it's the greater thing.
Anybody else make a mistake? Yeah.
I just got a question. I didn't know which one to say green, the yellow.
It's where they overlap. It's where the two overlap. It's where so if I have two lines that cross, I got 4 possibilities because I have up here, I have down here, I have over here, and I have over here, right? So I only have 4 possibilities. So it's got to be the spot where both of these lines intersect, or both of the shaded parts intersect. Here, only one part is shaded. Here, nothing is shaded. Here, one thing is shaded. Here, both of them overlap and they're shaded. Does that make sense? So it's the same thing here, that here, this whole side is shaded, but here only shaded orange. So like it's the part here where you've got the blue and you have the pink that overlap, where they're both shaded together. That's where the yellow is. That's where the solution region is. Does that make sense? Okay. So now you guys are equipped. You will be able to do the back side of the homework now. So that is the back side of the homework. Okay, any questions over graphing inequalities? So now we're going to move on to the stuff that we're doing today. So find the notes for today. It says solving systems using substitution. Solving systems using substitution. Does anybody need to come get it? Because maybe you didn't get it before. Solving systems using substitution. If you need to come get it, come get it. Yep. Instead of doing a brain break, I have not really introduced myself at all. And so this is my family. I love my family. We're a real hot mess. And so these are my boys. He graduated a couple years ago and he graduates this year. He goes to Cedar Ridge. This is my daughter. She is in 5th grade. And then this is my fiance. If y'all haven't seen him, he's a cooking teacher. And these are his daughters. She goes to UTSA and she is in 7th grade. These are girlfriends. He has a girlfriend too, but she didn't come with us to that picture. So that is my family. So sometimes I will talk about them. Yes?
One of the blue is both y'all. You and Mr. Listening.
Say that one more time. The one in the blue is what?
I said the girl in the blue is you and Mr. Furniture. Or
No.
no?
Nope. Last weekend, he asked me to marry him. And so I've had some students ask me about that. And so I thought I'd share it with you. our kids kind of don't live close. And so he had them take pictures. Well, they live with us, but she lives in San Antonio and he lives in Leander. So he didn't think he would be able to get us all together. So he was going to take pictures and show that to me. But it just so happened that last weekend we were all together. So we had them all at the same place, same time. So he had them all hold the pictures. So it was really cute. It was sweet. It was exactly what I would want, that he had the kids involved. I was very surprised. So probably sometime in October, we'll get married and probably go on a trip. So that is a little bit about me. I usually wait a little bit to kind of introduce myself because I have kids move in and move out and shift. And so I want to make sure that more kids are permanently in here before I kind of introduce myself. But that is me and my perfectly imperfect family. So now we're going to go to our notes, and I wish I could get that screen off so that you guys could see the title, but it's in front of you. So the notes, solving systems using substitution. So we learned about how to solve one system or systems last class, and it was just graphing. When you graph them, you look for the intersection, and it's the point where the two lines are equal. So now what we're going to do is we're going to find the solution, but not graphically. We're going to show algebraically. There's some advantages or some reasons why I would show you different methods, because sometimes you get a system of equations and they're written in different ways. So it is in your best interest to graph if you already have one or both equations and they're already in y equals form. Y equals form is slope-intercept form. Slope-intercept form. So if you're already in slope-intercept form, or it's really easy to make one of the equations in slope-intercept form, and we did that a little bit last class, then graph. You can always graph to find your solution. Sometimes it is easier to do substitution. And some people like substitution better because maybe you struggle with graphing. So again, we're going to learn 3 different ways to solve these. So one reason you would use substitution is when one of the equations is already written as x equals or y equals, especially if one of them is x equals. Well, you would have to rearrange it all to get it as y equals to be able to graph it. So it's easier to just use substitution if you already have x equals or y equals for one of them. So just like the name implies, when you use the substitution method, you will, what do you think? If it's called the substitution method, what do you think you're going to be doing? If you're using the substitution method, well, let's go back. If you're using the graphing method, we graphed to find the solution. If we're using the substitution method, what do you think you're going to be doing? Substituting. So if you're using the substitution method, you will substitute to solve for one variable. And then you will substitute again to solve for the other. And substituting in math is just taking something and plugging it into the other one. So substitution method, we will substitute. Let's do it. So this one, do you see how this equation, it's not both y equals, right? So sometimes they're set up that in this situation, you could graph it. You would have to get this one in y equals first. And so there's some steps you'd have to do. You'd have to subtract 4x, and then you'd have to divide by -3. So you could do it. You could do graphing. But if you already have one that's y equals or x equals, then it's probably just easier to use substitution method. Let me see if I can bring this down so y'all can see it. Oops. Okay, that's better. So if you're using substitution method, we're going to take the y equals part. We're going to take that y equals stuff, and we're going to take that stuff. Okay, we're going to take this y equals stuff, and we're going to plug it in wherever we see y equals. We're going to take it and we're going to plug it into the other equation where I see y equals. So I'm going to rewrite that equation. Let me see if it looks better highlighted. I'm going to take that stuff and I'm going to plug it in right there. And I'm going to rewrite it. So everybody see what I just did? Any questions? I took y equals and I plugged it into y for the second equation. Anybody confused by what I just did?
Yeah.
Who said yeah? Okay, so I took, and you gotta make sure you're not talking, because if you're talking while I'm explaining things, then that's why we miss stuff. So we're gonna take this y equals part and we're gonna plug it into the other one where I see y. So that's what I did. Instead of writing y right here, I wrote what y is equal to. So now all I'm going to do is evaluate. Now I have an equation that only has x's. So I'm going to solve it. I'm going to solve for x. So this is that PEMDAS stuff. First thing that I'm going to have to do is distribute. Negative times a positive, that will be negative 6x. Negative times a negative would be positive 9. I need to combine like terms. So negative 6, and I'm getting 4 more positive. Do what? Negative 2x. And now we're at a simple two-step equation. I always have to take care of addition, subtraction first. So first I will subtract 9. Very good. And then last, I will divide by negative 2. So x equals what? So that will become positive 2. Do what? Positive 2. So that is part of my solution, but I need an x and a y. So now that I have my first solution, or first part of my solution, and to write it as a point, I have this part, but I don't have the y part. I also have part of the other way that I'm going to write it. I'm also going to say x is equal to 2 and y is equal to whatever the y is. So now I can take this x equals and I can plug it into either equation to get my answer. If what I want is y equals, which equation is going to do that easier for me? If what I want is y equals, I have this equation or this one. Which one is going to be easier to plug into? The top one, because it's already y equals. We'll make it easier. I could plug it into this one, but I'm going to have more work. So yeah, I would plug it into that top one. So I'm going to plug in. So this is my second thing I'm solving for. So now I'm going to take that x equals 2 and I'm going to plug it into this one. I get y is equal to 2 times x, which I know is 2, minus 3. So y is equal to 2 times 2, which is 4, minus 3. What is y equal to? 1. Good job. So y is equal to 1. So you will first substitute to solve for one of the variables. Take that variable, plug it into one of the equations, and solve for the other. The solution or the answer is the point that makes both equations true. So if you're doing your test and you are really wanting to know, did I do this problem right? You can always take your X and your Y and you can plug it into both in both equations. So I could take the X for 2, X equals 2, and I could plug it in here. And I could take the Y is equal to 1 and I could plug it into here. It has to make this side equal this side. And if it works, then it's true. It has to work in both of them. So that's how you check your solution. The next one, do we have an equation that's solved as either X equals or Y equals? Yes, so easy. We're going to take it and plug it into the other one. So it's the same idea that this time it's the bottom one. It's X equals, and I'm going to take that and I'm going to plug it in right there where I see X. And so I'm going to rewrite it. And when I plug it in, I'm always going to use parentheses. So this was the stuff that I just plugged in. And then I'm going to solve. So I'm going to solve for Y. My first step is to distribute. Oh, perfect. Did y'all get the same thing? Yes, no? It's still early in the morning, so I'm just making sure that my math is good. Do y'all agree? All right. So the next step, we need to combine like terms. This is just like the other one. So -6 and 4, yes, it makes -2, but -2y plus 10 is equal to 0. Now we're at a simple two-step equation. I'm going to have to subtract 10. Zero minus 10 is -10. All of a sudden, we see a 0 in a problem and we think we've done something wrong. Don't think you've done something wrong. And then my very last step, I need to divide by -2. Negative divided by negative, that's going to be a positive. Y is equal to what? 5. So now I can look at my solution. I found out Y is equal to 5. So I know Y is equal to 5. So if Y is equal to 5, I can take that and I can go plug it into one of those equations. Which equation is going to be easier to plug into? The bottom one, right? Because it's already set up as X equals. So let's plug it into this bottom one. So when I go to plug it in, X is equal to 3, and I know that Y is 5 minus 5. So X is equal to 3 times 5, which is 15, minus 5. X is equal to what? 10. And that is my solution. Again, the reason why I'm making you write it both ways, sometimes on your test, it asks you about the solution and it's given as a point. Sometimes I ask you just for the Y coordinate. So we need to be able to identify both. Can you give me a thumbs up, thumbs down, or thumbs in the middle where we're at right now so far? Okay, so most of us are doing okay. If you're kind of here, then make sure that you're really paying attention. The next one, we have another equation, and is one of them x equals or y equals? Yes, so we can use substitution. Especially in this situation, like graphing it is going to be more difficult. You're going to take more time trying to graph it than you are to just use substitution. So for this one, yes, we have an x equals equation. So x is equal to that. So I'm going to look at my other one, and that's where I will plug it in. So I will rewrite that equation. And I will plug in the stuff for x. All right, that's my reminder for attendance. Yesterday I got in trouble because I guess it was too early.
Teachers, please pardon the interruption. This is again a reminder that the tone you just heard was the reminder bell for your second period attendance. Again, the tone that you just heard was your reminder for your second period attendance.
So I am still missing Jalen Thomas. Okay. All right, so I'm going to evaluate this. It's the same steps over and over again. I'm going to have to distribute. And now I need to combine like terms. Huh. Well, 12 minus 12 is what? That's 0. Well, I get 0 for my variables. I have 0 y's. And I still need to find out what's on the other side. So if I have positive 18 over here, I would have to subtract 18. So really what I end up with is that 0 is equal to negative 15. Is that true? No. If I have 0 y's, then I have none of them. I don't have to write it. So what I end up with is a math statement. 0 is equal to negative 15. Is that true? No, that is not true. When something is not true, what does that mean? No solution. So my solution is no solution. We graphed last time. When we graphed last time, when did we get no solution? What kind of lines give us no solution? Parallel. There's no solution because these are parallel lines. There's no solution because they are parallel. Down here, there's a little box and it says sometimes we get special solutions. And that happens when your variable cancels out. That's what we just did. When we were solving it and then it's like, oh, my variable just disappears. So sometimes that will happen, not super often. You know, if you're doing 6 problems, maybe 2 of them are special, but the other 4 are just regular, you get a solution and it's normal. So when your variable cancels, there's only 2 options. And we saw this graphically last time. You either get no solution because it's not true, or the other situation is that you get a true statement. And when it's true, then what do you think the answer is if it's true? It's the third situation. Infinitely many. So we're going to jot that down inside of our statements. So I'm going to show you what it looks like algebraically. If it's false, you get something like 0 equals -15. That's not true. If you get a true statement, you'll get something like 0 equals 0. That is true. So when it is false, there is no solution. And it's no solution because really those lines are parallel. If you get a true statement, then you get something that equals itself. And for those, you get infinitely many solutions because it's the same equation. And I know it doesn't seem like it, and especially if they're not both in y equals form, sometimes it's not obvious that they're the same equation. How many more examples do we have? Okay. I don't think we have two. Don't we just have one? Just one. Well, before we do that, I just want you to take a couple deep breaths. We're almost done. We are almost done and we still have 30 minutes. So we got plenty of time. We can breathe. This is a lot of math that we've just done. We've done a day and a half of notes. So breathe with me, people. Okay. Sure. So the very last example, we got this. Okay. So let me pull this down. I forget that when I'm recording, you can't see. All right. Just because directions might say use the substitution method, because in your next quiz and on your test, there are going to be some problems where I say, oh, solve this one by graphing, solve this one using substitution. So just because the directions say use substitution does not mean that everything always sets up beautifully where you have an equation and then another one that's x equals or y equals. In fact, if you look at your homework, most of them are, but a few of them aren't. But I will tell you that just like graphing last time, that when we went to go graph them, not everything was in y equals, but everything that we had to do was simple. It was, oh, divide by 4. Oh, subtract 3x. It was simple. Same thing with substitution. I'm not going to tell you to use the substitution method if you have to do a bunch of stuff to both equations. So sometimes you have to make little adjustments first. So just because the directions say use the substitution method does not mean that you're ready to substitute. It means that it's probably going to be the easiest method. I'm trying to help you figure out which method, because some of y'all would look at your quiz or look at your test and be like, I have no idea how to do this one. So when you look at these, they're actually both in standard form. But neither one is x equals, neither one is y equals, but there is one of those that is going to be easier to fix. Which one? Yeah, why? Yeah, because it's just really easy. Like if you're going to start doing the bottom one, you would have to, either one of them, you subtract something and then you have to divide. Well, the top one, all you have to do to get y by itself is to add 2x to the other side. And then you're ready to go. So we're going to do that first. We're going to get this first one. We're going to take the 2x over here and subtract 2x. So I will rewrite that equation. That becomes y is equal to negative 2x plus 5. All I did was subtract the 2x. Now, do I have an x equals or y equals equation? Yes. Now I can substitute. So I will first figure out where it's going. I have negative 2x plus 5, and I'm going to have to plug that in wherever I see y equals. Hello. Uh-huh. Thanks. Cortez Castellan, that one's you. Mhm. So we are going to plug that in and we're going to solve for x first. Nope. If you were to accidentally plug it into the wrong place, what you would end up with is an equation that still has x and y in it. So you can't solve for anything. So you did something wrong. So whenever you plug it in, if you plug it in correctly, then you get an equation with only one variable. All right, so I'm going to distribute. Nope. And then I need to combine like terms. What happens? The variables cancel each other out, but I can't stop there because I had to figure out, do I have a true statement or a false statement? So those are going to cancel, yes. It's going to leave me with 6 minus 6 is 0. But I also have to take this over here to find out, am I going to get a true statement or a false one? So 15 minus 15 gives me 0. It's true. It's a true statement. And so what is my solution? Infinitely many solutions. Why do you get infinitely many solutions? It's the same equation. That's why. They're the same line. All right, we got done with that in record time. So you have plenty of time to go get started on your assignment. Yes. Also, if you didn't finish your dot to dot picture, you could also work on that, but I feel like that is really super simple. So what I would probably do is work on the homework because you have friends and people in here to get help. If you didn't already turn in the little half sheet, please make sure that you turn that in. Any questions over what you should be doing right now?